Okay, so now we are starting the data visualization. Now this is very important. In fact, if you have learned this, half of your problems can be solved just by creating data visualization. So the understanding of this is very essential, and you must go through again and again so that you can have a good grasp of this. So again, as usual, let us clear all the outputs, and then we can start our learning. So here we have cleared all of them. We have given the command to clear all the outputs. You can see all these outputs are already there, but now we have cleared it. So let's start it now. So the heading is of course the DV training, basic charts, and of course these are basic, but then they are very important, and most of the time you will be using these kinds of charts. So let's run it. Here of course nothing is going to happen. Then we are going to import the NumPy, Pandas, Seaborn, Matplotlib, etc., which are again basic requirements. We'll keep on importing the data as per our requirements. So we'll see whenever it is required we can import the data. So now we are importing the NumPy, Pandas, Seaborn, and Matplotlib. These are the libraries which are required for doing various visualizations. The next that we are going to do is to import the employee data, just to do some exercise on the employees, that is emp.csv. So this NumPy etc. has been imported. So we are going to import this data file now, which is again a data frame. We have given this. Then Pandas is the data that we are going to use, and this is CSV file available here. So run it so that it can come. Then we are going to create a bar chart. The bar chart is very common. We know that how it is created and used. So here variable is equal to df group by gender, because there are always a possibility that employees may be having males and females both. Then sales summary, then grouped sum of the sales at gender level. Figure is equal to plot figure, that is where we are going to create. Axis AX1, then subplot 1, 1, 1. Then X label is gender and Y is sum of sales. And title is gender wise sum of sales, and we are going to plot it. Kind is bar. So when we run it, you can see that a bar chart will get created. So this is how it is. Now whatever code we have written here, you can see that gender wise sum of sales. On y-axis we are having sum of sales, on x-axis we are having gender. Here we are having the male and female, right? So males have given more sales than females, right? So this is the kind of bar chart that we can generate. Very simple codes are there, and of course the data file has to be there. Then the next is line chart. Line chart are also commonly used, and for that we have to give again variable df group by now BMI, that is body mass index, sales sum, and then again PLT figure, add subplot 1, 1, X label BMI, Y label sum of sales. So we are now going to create a line chart based on the BMI. So you can again run using the same data file. So since the data file is same, we are creating another kind of a chart, that is line chart here. So this line chart can be created. This is BMI wise sum of sales. This is the sum of sales, and this is the obesity, overweight, underweight. This is the BMI. BMI, we know there is a body mass index, right? So this is again a very simple graph line chart. Then it is an area chart. Area plots are pretty much similar to the line chart, line plot. They are also known as stack plots. These plots can be used to track changes over time for 2 or more So this is very useful chart again. And again we can create this chart by importing matplotlib pyplot. Although it is already imported, no need to import it again, but it is better, so that in case it is not, it may give error, so it is better to do it. Then days 1 2 3 4 5, 5 days data is there, and the kind of data is sleeping, eating, working, playing, and how many hours that we have done what. So this is a plot. Color, sleeping, line width is S, again 5, then again for eating 5, working 5, and playing 5. So these are the different colors that we are using, MCRK. These are different codes of colors, right? So we can use that. Then plot, stack plot, days, sleeping, eating. These are the various variables that we are considering, and these are the various colors. So depending on these colors, and of course what we have done, so that can be presented in a form of the graph of this area plot. Plot X label X, Y label Y, stack plot, and legend. And then plot legend means that you are going to show that which color is doing what, right? So once we run it, you will see that it is this, right? So this is how you can get the stack plot. You can say sleeping, we have spent, this is the sleeping part, then this is the eating part, then this is the working, and then this is the playing. So this is how you can create a stack plot or an area plot. Now here next we are going to have a scatter plot. Scatter plot is, again we have seen earlier also, figure PLT figure, AX fig, add subplot 111, AX scatter, and DF the data frame that we have, age, sales. You can also add more variables if you want. So this is just for our, since we are learning, so we can always try like this. So title is scatter plot, X label is age, and Y label is sales. So again we can run this, and we can see that we can get a scatter plot using the same data. So this is how you will get the scatter plot. Since the data is not much, so we are getting this slightly distributed kind of a scatter plot. But sometimes you get a very dense, very condensed kind of a scatter. So depending on the data, it will come here. Now there is another type of plot, that is bubble plot, which is plot figure, again using the same data that we are using, AX scatter, DF age, sales, income, and then bubble plot, age, sales, and then go for the display of that plot. This is going to be a bubble plot. Now bubble plot is again useful because here you are going to see the size of the bubble. That will guide you, that will help you to understand that how much sale is taking place at that particular point. So this is the distribution of the age, and this is the sales. So this bubble becomes very important in such cases, right? Now moving on further, pie chart. Now pie chart is again very common. I think everybody must have seen it. And the pie chart is a oval by default, but to make it a circle, use pie plot dot axis. So to show the percentage of each pie slice, pass an output format to the auto parameter, auto percent parameter. So you can create the percentage of that with the help of, this is what for our understanding, that is plt.py, x list labels, labels, s labels, then list auto percentage. This is the way we can write it, and this of course is for remarks. Now once we write the code, variable is called df dot group by gender, and sum of course, that of course is required. Then temporary again is a variable, unstack, type is temporary, x list sales, because on x axis we are having sales, label list is temporary index, pie plot, and this is of course the label list auto percentage. Now whatever we have seen here, the same thing is put here in the code, and then the title is pasta farianism expenses. So when we print it, give the command to print, you can see this kind of a pasta farianism expenses are displayed, and this of course with the percentage. The percentage is displayed because of this code that we have written here, auto percentage. So automatically whatever is the size of the pie, it will give you the percentage of that, right? So this is how you can create the pie chart. Now coming to histogram. Now histogram is again quite commonly used. It is again like figure, PLT figure, plots in matplotlib reside within a figure object. Use PLT figure to create one or more subplots using add subplot, because you can't create blank figures. So this is the way that you can write. Again, you will see that by and large everywhere same pattern is there. Only thing that somewhere you will find some differences. Ax is equal to figure add subplot 111 variable ax hist. This is the histogram. Df age bins are 7. Here you can play with number of bins, and of course depending on your requirement or how you want to present your data, labels are tit. Title is age distribution. Then X label we are having the age, and Y label we are having the employees. So once we print it, you can see when you execute it, you are going to get a age distribution. Now here on this x-axis you are having age distribution, and here you are having the number of employees in that particular. So we have created 7. So 1, 2, 3, 4, 5, 6, 7 age groups are there. So this is the range, because you can't give for each and every individual employee's age. So you have to give a group of the employees in that particular age group, and this is the number of employees in that particular age group, right? So this is again a very useful kind of a way we can present the histogram, right? Then moving on, we can also create a violin plot. Now violin plot is not very commonly used. In fact, this is something which is very unique situations we need it. So here we have to import the cboard, because now we are going to use cboard. Plot title is violin plot, SNS violin, violin plot, and data frame is of course age, gender, and you are going to create a despine, that is the kind of plot that you are going to create. So when we run this, you will see that it will create a violin plot. Now this is a violin plot. Age is distributed here, and gender. Now violin plot, particularly the peculiarity of this is that it starts with a very narrow point, and then it expands, and then again towards the end it again shrinks to again creates a kind of a point. So that is that depends on the data, of course. So whatever type of data that you have, the violin will get expanded or shrinked. So that is again a very good indication of getting the information from the graph itself. So these graphs are very informative. That is why half of your problems can easily be solved with the help of this kind of plots. Now we are moving on to the stacked column chart. Now stacked column chart is variable again df group by BMI gender, that again we are considering because these are the two variables available. Sales dot sum, then variable unstack plot kind bar, this is the bar type, and stacked true, that means it will be there. Color red and blue, these two colors we are giving for two different kind of a gender, and grid is equal to true. So we need the grid also. So when we execute it, you can see that you are going to have a this kind of a graph where red is the female and blue is male, and this is the normal, obesity, overweight and underweight. So these are the the bar. From the bar itself you can say that how many guys or girls are in that particular range, say category, that is obesity or normal, etc. And these are the of course your number of people in that, right? So this is again very informative thing. Then further on to this, we are now going for heat map. Now heat map is something which is again very useful and informative and commonly used. Is that again import numpy, again no need to, but it is better. Data is equal to rand, we are creating a different type of a data for this. Rows list 1 2 3 4, columns mf male and female column categories, figure of course ax plt subplots, these are the subplots that we are going to have. Then ax p color data, color map is equal to plt.cm reds, edge color is equal to k, K is again is a code. Ax dot set x ticks np arrange 0 2 plus 0.5, again in the same fashion for y ticks. These are different two different axes, x axis and y axis. So what is how it is going to be distributed. Then here we position the tick labels for x and y. So x axis tick bottom and y axis tick left. So values against each other. Now ax set x tick labels, then umns minor false, font size is equal to 20. Ax set y tick labels row minor false, font size is equal to 20. And when we go for the showing of this particular graph, that is heat map, you will see that how this heat map is going to be created. And this is how, because this is male, female, and these are the different types of number that we have given, that is 1 2 3 4. Accordingly it has created that. So this again is quite useful, and whenever it is required we can use it. Then next comes the again importing seaborn iris. Now we are going to use the iris data. Iris data, as we have discussed earlier also, there is a flower, and it has three types of flower, that is setosa, vernacular and vernacular. And import matplotlib, seaborn, and then you are going to create a. So here we are just importing, we are not doing anything as such, but we are importing the libraries and the data itself. So here we are going to simply execute it, run it. Now you, as usual, if you want, you can check this various and these are again because we have given the command here like import seaborn, and then we are getting this sb.get dataset. So we are getting these dataset names. That is why this is appearing here. Otherwise it would not have come, right? So these are the datasets which are available in this, right? So moving on further, you can print the iris.head. So you will see that again the iris sepal length, sepal width, petal length, petal width, species and species are setosa and vernacular and vesifora. All that will be available because we are seeing only the 5 top records. Print iris columns. You can see the iris columns also will be printed like this in the same fashion as it is here. These are all columns, and again you can get only the columns here with this. Then iris species, if you want, you can get the species only, the name of the species. That again you can get, like versicolor, there are 50 records. Virginica, there are 50 records. Setosa, there is a 50 records. So this is a detail of your data that you have. That means total we have 150 records. Scatter plot for this can be created by iris.plot kind scatter. X is sepal length, Y is sepal width. And when we show the plot, you can see that a scatter plot will be generated. This is the way it can be generated. Now you can see that here you are having the sepal width and here we are having sepal length, but they are all mixed together. That means all these 3 types of that versicolor, virginica and setosa all are mixed. So we can't distinguish because all of them are having the blue color. Only thing that we can get is that this is the sepal width and this is sepal length, but we cannot go for any distinction between the 3 different types of flowers that we have, right? So to do that, we can go for n in range 0 to 150, because total number of records are 150. So out of that, how many are setosa and how many are versicolor and how many are virginia, we have to find out. So if iris species is equal to n setosa, then plot scatter iris sepal length n iris sepal width and color is equal to red. Now we are giving different colors to different species, that is setosa. Now for setosa we are giving red. Similarly, else if it is not there, then else if iris species is equal to versicolor, then plot scatter iris sepal length is this and the color is going to be blue in this case. Then again X label, sepal length, these axes are same, so we are not changing anything in that, but yes, the colors we are changing. Similarly for the next, that is elif iris, here if it is virginica, then again you are going to give a color green. So you can see that easily now we can have some distinction, right? And when we go for the plot show, you will see that 3 different colors of each of these. Scatter plot will be same, but the color will be available to you. So this is how you can, because we have given the red, blue and green. So that is how this scatter plot has been created, giving us now that this is setosa or Virginia or versicolor, whatever is there that we can get. So it becomes more informative now, right? Now moving on further, no, but still we find that here again we are not getting that which one is it's setosa and which one is Virginia and which one versicolars. That also can be seen. So the plot is all mixed up. It is not possible to distinguish which data point belongs to which species. Therefore, if we color it, we can easily distinguish that. Of course we did. So we need to write the following code here for plotting. So we have done. So we can run this also. Now import seaborn as this white grid, and this is iris hue is equal to species, and size 4. This is for the continuation of the line, because the codes are being continued. Map, PLT scatter, sepal length, sepal width, and then we are going to add legend. Now we are going to add legend. Legend means that now we can understand that which color is what. That is the purpose. And when we show the plot, you will see that we are going to have another see, here we are going to get now 3 different colors with label. That means species setosa is blue, versicolor is, this color has been created on its own because we have not specified the color. So if earlier we had given the color, but this time we have not given the color. So colors have been created by its own. So setosa is now blue, versicolor is this orange, and Virginia is green. So this again is very helpful. If you wanted, we could have given the color also there in the same fashion, right? So this is how you can keep on improving your graph and make it more and more informative. Now we are going to create the pair plot. Now pair plot is again very useful. And how it is created? Again, the same data set that we are going to use, and now we are going to create couple of small graphs. So let's see how that is done. When we run it, this process. So pair plot SNS set style is white grid, because it is going to have on the white background, and white grid is going to be there. Pair plot is going to be created, and then iris is the data set, size is equal to 3, and plot row. So we can see that this kind of a graph, when you want to create, you will see that how it gets created. This is something which is again very useful and very informative, and you will have multiple graphs. In one big graph you will have small graphs. Now these graphs are again like this. You can see one big graph, and then these are like, and it's a combination of here you have sepal length, sepal width. Now these are the histograms, scatter plot. So this is the way you can create for different types of species and colors of with the species, and of course the type of whether the sepal width and sepal length, etc. That all is you can get from this. So this type of graphs are also possible, and you can use it for your purposes. Now next is, again you can create the SNS pair plot with the same data set. You can have, again you can continue, and you will again have the pair plot, but this time it is going to be a different size, and we are also having hue species. Size is equal to 3, and pair plot of course is same. So that's how you can have it. So like that you can create many such graphs which are fairly informative and of course usable in various kind of understanding and analysis. So there is no need to go for a tabular kind of a output. These graphs are sufficient for us. Unless you want to be very particular about having the exact figures, you don't need to go for that. By and large, you would see in the commercial arena, organizations or manufacturing, or for marketing purposes, even these kinds of graphs become very handy, very useful. So therefore, that is why your half of that work is only done with this help of the various kind of graphs like this. Now here again you can see that beautiful graphs can be created with the help of this, and it is almost by and large the same type. Only thing that now with a small difference that you can see, and because of that you are getting the labels also, right? So different kinds of graphs and different colors can be created with this. Now moving on further, again another type of pair plot, iris hue species palette hus1, and then so you can again run this, and you will see that again a similar type of plot will get created. So you can see again another type of, because we have given the palette as hus1, so that is why it is created like this, hustle, in fact HUSL. So that is why this gives a different color. Otherwise the graph type is by and large same, but because of this hue HUSL that we have given, we have got a different color combination, right? Then again another, now we want only the blue color, suppose. So that also is possible, and we can run the same, the only thing that here palette we have given as blue D. So when we run it, you can see that the color will again change only to blue color. So it depends, up to the analyst or the person who's working on it. Whatever, how improvements, what kind of improvements he wants, he can keep on trying all this, and whatever looks good he can use it. Some people have some fancy for a particular type of color, they can use that. Some people have some fancy for a particular type of graph, that also they can go for. So whatever that is for, but different facilities are available, and one can use it the way he wants it. So that is how you can have a similar type of pair plot having this kind of a code. Yeah, see, the it is all blue color based, right? And blue, of course, is coming in a different shade. So that is why if you see the code, it is blues underscore D. So different colors of blues, shades of blues have been there, have been given there. Now next is that we are going to draw a graph establishing a relationship with two variables only, like pair plot. Then we are going to establish relationship between species and sepal length, sepal width. So these are the two variables, right? So when we give a command to execute it, run it, you will see that again we are going to have again a pair plot, but now we are getting a relationship between the different species with sepal length and sepal width. So what is that we can see here just by looking at this, So these are the kinds of graphs which are very, very useful, and you can go to the micro level, deep into this. So this is something which is again very helpful. Again, we draw graph for all the species with sepal and petal length in consideration, and this is where again we can create a pair plot: iris, hue, species, x variable, sepal length and sepal width, and this is x variable and y variable is petal length. So we can have both of them: sepal length, sepal width, petal length, petal width, and again we are going to create a graph. So now we are getting both the x and y variables and giving the sepal length, sepal width, petal length, petal width, and again pair plot for that. So this is how we can keep on creating. Now see here, these are the kinds of petal length, and then we are having the sepal length, sepal width, petal length, petal width, and these are the different say species that we have: blue, orange, and that is setosa, versicolor, etc. So that is how you can get it. So you can, depending on your requirement, you can create these types of pair plots. Now moving on to another type of plot, that is GG plot, plotting the features using box plot. Now box plot is not very commonly, but it is definitely used and quite informative. So let's run this. Of course nothing is going to happen in this because it is remark. So GG plot is again style, and all through you must have seen that creating the plot, the code is very simple. Only thing that you have to practice once or twice, and then I think you will be familiar with that. So PLT style use GG plot, type of plot, subplot 221, SNS box plot, species y sepal length, data is again iris, that is the same data, plot subplot 222, then SNS box plot species, again sepal width, then see petal length and petal width. So the code is same, only thing that we are changing this, and subplot is also changing from 221, 222, 223, 224, right? This is the only change that we are having, otherwise the code is by and large the same. So when we run it, you will see that another type of plot will get created. This is the box plot. Now box plot again, because it is a kind of a four graphs, four small, because we have asked for 4. If you see the code, we have asked for 221, 222. So these are the 4 types of, and that is why they are appearing in 4 quadrants, right? And data is same, of course. And here we are having sepal length, sepal width, petal. These are again different combination for different species. So that is why for everything that you are getting in one graph itself. Now that is something which is again a very useful way of getting your graphs, which is quite informative. Now representing the data using violent form. Now same thing that you can present in the violent form also, right? So if you want to present in the violent form, again this is remark, so we can just run it, nothing is going to happen. But again, you see, now GG plot is this only. This is the type of plot, that is GG plot. But here we are changing the type of graph within that. That is, here we are getting the violent. So violent plot, again other things are going to be same. Data is same, sepal length, this is also same, and this these things are also same, 221, 222. Only thing that now the shape is going to be different. So when we run it, you can again see that instead of box plot, now you are getting the violin plot. So this is the way you are going to get the violin plot. See again the 4 quadrants, and you are getting the violin plots within that. It depends if you need it, because this gives a different kind of information also, because it is getting enlarged in the middle, and then on the top and bottom they are becoming pointed ones. Now we are going for a joint plot. Now this type of plot is not very common, but if you need it, it will be quite useful. So this is again like SNS joint plot, sepal length, sepal width, data is same, iris. So we can run that so that we can create this. Now we are going to create a strip plot with the help of that. So this is the way that we can create the. So see here, this is the SNS joint plot that we have created. This is the name of this plot is joint plot, right? And data of course is same, iris, petal length is a sepal length, sepal width. Between that we have got it, and the sepal width, and here it is sepal length, and we are getting 3 types of graphs within one graph itself. So this is scatter plot, then you have got histogram, both horizontal and vertical. Now it depends how if you want to use it, you can use it. If you don't want, of course, but you will create only when you need it. So this is known as joint plot, right? Now here we are going to have the strip plot now, and again it is here only thing that instead of violin we are getting we are writing strip plot. Again the data is same. Now here one thing new that you are seeing is jitter is equal to true. Now I'll explain you what is jitter so that you can understand what exactly we mean by that. When the graph will come, then I'll explain it. So this is the code is same. Now jitter is that what is the width of these points, data point that we have. Like here within the graph itself, it is otherwise it is the same as the the earlier plots, like this violin or box plot. But here you can see these where it is quite dense, these red color or blue color or cyan color or whatever, these can be narrowed or this can be spread. So that is coming with the help of the jitter. If jitter is equal to true, it will spread out. If it is not true, then it will be a very thin type of a line. So that again depends on your requirement. If you want, you can expand it, spread it out, or if you don't want, leave it. So this facility is also there with the help of the jitter command, which is available here. Now moving on further, data visualization for flights data. Now this is something which is again a different kind of a data set that we are going to use here. Now this matplotlib tries to make easy things easy and hard things possible. Seaborn tries to make a well-defined set of hard things easy too. Now Michael Wasken, creator of the Seaborn, has said that. So we can run this. Of course nothing is going to happen in this, but here we can see that again we are importing. Why we are importing? Because we have done so much, quite possible that some disturbance may be there, so it is better to import it again. Otherwise it is not required if it is already there, right? But there is no harm in doing it, because you are simply writing it again. And again the same thing, pandas, numpy, matplotlib, this and that. Now with this, from BS4 import beautiful soup. Now this is something which is new, which comes from the Seaborn. So beautiful soup 4 is another library which is part of the Seaborn, and you are importing from that only this beautiful soup only. So we have already executed this. Now we are going to have the flights data. Now flights data, in this there are some passengers, and we are trying to analyze that how these passengers are going to be distributed for various purposes. So when we run it, of course the data has come into data frame. Of course we are going to get the top 5 records like this. Now these are the years. This year 1949, from January to say December, how the passengers have flown, you know. So that is what our analysis, the purpose is. So we can again get some information about the data types. The year is integer, month is category, passengers are again integer. Now when we describe it, you can see that it is something which is, like all the statistical, information, year and passengers, then mean, standard deviation, mean, minimum, and then percentiles, all that is possible. These are not otherwise required, but it is better to understand your data as intimately as possible. So when you can run about the information, that also you can get with this, code, range, data, year, month, passengers. Then you are going to get the data set names. So that also you can get with the help of this. So these are the data names. As you remember, we have got for iris. Similarly, we can get for the flights also. These are the data names that you have, right? Now these are all exploratory. We are exploring the data set. That is why it is known as exploratory data analysis, EDA, or in short, data exploration. Now we are going to go for some further analysis. Now this is like the process of understanding relationship between variables of a data set and how these relationships in turn depends on other variables is known as statistical analysis. Let's now take a deeper look at functions needed for this. So we are going to have rel plot. This is figure level function that makes use of two other axis functions for visualizing statistical data. Like you can take it here, statistical relationship, which are scatter plot, line plot, and so these things are to be noted. Now we are going to again set our grids. So SNS set style, this is the style that we are going to set for. So we are running it. Of course nothing is going to happen, but this internally it has done. Then F is equal to SNS load data set flights, SNS rel plot. That is what our purpose. We want to establish the relationship between passengers and month, and data is equal to F. That is, F is the flight data has gone into F, and the same is being used here, right? So once we run it, it will again do something internally, and then we are giving with this command sns.rel plot x is equal to passengers, y is equal to month. So on the x-axis you are getting the passengers, that is 100, 200, like this, whatever is the number of passengers that flown, and this is the month. So this is again like informative enough that from the passengers data set that we have, how they used in different months, how many passengers, and month wise that is available in this. So this is again something that you can see. Now as you can see, the points are plotted in two-dimensional. However, you can add another dimension using the hue semantic. Now this is hue is going to do this. So let's take a look at the example of the same. So when we run this, nothing is going to happen because remark, but then again F SNS load, same data has been transferred to F. Then SNS rel plot passengers, y is equal to month, same thing, and hue is equal to year. So that means this will change. This will make us or give us more information. Now let's see how the plot is going to come. You see, the third dimension that we wanted to have in the same graph is that now year wise, in year it is slightly dim. In 1952 it is slightly darker, 56 it is still more darker, and 60 it is still darker. So that is why, because not much we can do about it with the two-dimensional kind of a graph, but at least by giving this kind of a color we have been able to give a third dimension. So months are same, data is of course same, again the number of passengers are same, but in which year, how many, in which year and in which month, what was the type of data that was there. That is what it is. So that is why it is again a different kind of a information that you are getting. Now, however, there are many more customization that you can try out, such as colors, styles, size, etc. Let me just show you how you can change the color in the following example. So we can again run it, nothing is going to happen, but we can definitely, the same thing that we are having, and you will see that with this command that you are going to do, that is, of course, the data is same, SNS rel plot, relationship plot that we are going to establish for again passengers, month, year, palette is equal to say character, and then R is equal to minus 0.51, L is equal to 0.75, and data is equal to F. So you can see that still more, coloring gives you still more information, different kind of, so more informative. That is the purpose. I mean, we can't do much, but whatever is possible, we can do with the help of these kind of facilities which are available. So you can go back, see again, and make your own conclusions from this. Now, where we are using a different data set, this function will allow us to draw a continuous line for your data. We can use this function by changing the kind parameter as follows. So if we run again, in this nothing is going to happen, but yes, when we go for this, you will see that data frame different days. Now this is a different data set. Now the flights data set is over. We are going to have a different data set now, and that is for the grocery items. Now these grocery items, you can see there in 5 days different kinds of groceries have been bought. Grocery, clothes, then the days, right? So if we run, see, how the graph comes. It's a line graph, and it gives that on these days how the purchase of clothes took place on different days, right? Now just by looking at the graph, you can see that how you can understand what is the trend that is taking place, right? Now plotting the categorical data, again you can see this approach comes into the picture when our main variable is further divided into discrete groups like categorical. This can be achieved using the cat plot function. Cat plot is again very useful. This is figure level function like rel plot. It can be characterized by 3 families of axis level functions named scatter plot, distribution plot, and estimate plots. So let's now make the few example with this. Now here you can see that again we are importing seaborn, matplotlib, etc., and we are using a different data set, that is tips. Now tips data set is for a restaurant. When the people visit the restaurant, they of course pay the tips to the waiter. So and entire data of course is there in the tips data, that of course we will see. We'll explore that also. So right now let us try and create a cat plot, that is category plots. So once we get the output, you can see that this is the total bill. Now suppose a group of people have visited, suppose your family has visited to the restaurant, and after making all this, after dining, etc., you pay the bill. So how do you pay the bill? Total bill is this much. This again, and this is the day. Thursday, Friday, Saturday, and Sunday. 4 days data is there, right? And this of course the jitter part. Jitter part has already explained that how dense or spread it is, right? And this is the way you can create it. That SNS set style ticks, color code is equal to true, and A is equal to this. That is data set tips, and you can create this, and data is equal to A. So day wise and total bill, how the data, right? The data name has been given as tips data, but of course it is the people who visit the restaurant, and whatever expenditure they do there, that is what the data is about. So as we can see in the above example, we have not set the kind parameter. We have not put any kind, that whether it is the bar graph or pie chart or whatever. So that we have not put it, and this graph has come on its own. So we can see that we have not set the kind of parameter. Therefore, it has returned the graph as the default scatter plot. Right? It is default. You can specify any of the axis, like level function, to change the graph as need be. So you can do that if you want. Let's take an example of this. If you want, you can take an example of this and see how it changes. Now import Seaborn again as SNS, import matplotlib. Again SNS styles ticks, color code is equal to true. A is SNS load dataset tips, the same dataset. SNS cat plot, day, again total bill, kind is violin. Now we have given the kind as violin. So that means now we are going to get the chart or the graph as violin type, and data is of course A. Right? So the same data set, and now you are going to get the violin kind. So these are 4 days, that is Thursday, Friday, Saturday, Sunday, and total bill. And now you can see that at what time the number of people who have visited is more. This is your violence width tells you. So this again is quite informative and quite interesting, right? So the above output shows the violin in plot for the tips dataset. Now let us try to find out how to visualize the distribution of a dataset. So we can do that. Here of course nothing will happen, but this is the cat plot in Boxen kind. So we can get the different, which is similar to the box plot, but this is known as Boxen kind of a shape, like this. You can see again a box plot, but kind of box plot named as Boxen plot, and again the same data, total bill and day. This again gives a different, it's a slightly rectangular type of a graph within that cylindrical kind. So this again is a type of graph that you can get. Now dist plot lets you show a histogram with a line on it. This can be shown in the all kinds of variations. We use Seaborn in combination with the matplotlib, the Python plotting module. The dist plot function combines the matplotlib dist function with the Seaborn, and for this we need to import the stats module from the SciPy as shown. So let's go for this. This again nothing is going to happen, but here we are going to import the stats from SciPy, because we are going to make use of this also. That is imported now. C NP random normal LOC 5 size 100 scale 2. So with this of course nothing is going to happen. I mean no result will come out, but then it has done internally. Now SB dist plot. Now we are going to create a dist plot. Now this dist plot is nothing but the distribution plot, that how this total data has been distributed over this particular range from minus 2.5, 2.55 to 12.5, and this is again, so this is the way you can understand that how and this is the normal distribution curve. So this is the way you can get the distribution plot also from this. Now the next is the distribution of data set. Again we are importing some same libraries, so you can run it. After running you can get, nothing will happen. We have plotted a graph for the variable whole volumes are generated, and the normal function using dist plot, plotting by bivariate distribution. This comes into picture when you have two random independent variables resulting in some probable event. The best function is plot these type of graphs is joint plot. Let's now plot a bivariate graph in this. So you can see that even that can be created. Now here we are having the XPD data frame day. Now day wise, 7 days grocery items, then clothes, then again this is for the different variable y, again day, grocery, clothes, and this is the mean and covariance. So data is again random, multivariate, normal, mean, covariance 200, and then with SNS we can see that how this joint plot can be created. So we can run it because the data already is, we have already created the data in this, and this of course the code that we have written to create the graph for this joint plot in this case again, and see that how this is going to appear. Right, so this is the kind of a joint plot that we have got from with the help of this data set, and you can see that how how different it is from the earlier plots and how informative. Here it is so dense, that means here maximum kind of a purchases of items have been done, and these are of course on y-axis we are having this day wise grocery and clothes, and here we are having again the grocery and clothes, and this is the way it has been distributed. This again is a normal distribution, again curve wise, and this is the strength wise. You can see the plot. So this is again different types of graphs are really very very useful, and whenever you need what you can always decide and use it. Now multi-plot grids. Multi-plot grids are something which are again quite useful in the sense multi-plot grids is Python Seaborn allows you to plot multiple grids side by side. These are basically plots or graphs that are plotted using the same plot, same scale and axis to avoid comparison between them. This in turn helps the programmer to differentiate quickly between the plots and obtain large amounts of information. So consider the following example. Now this is of course the remarks, but here you are going to have the SNS set style dark grid, SNS load dataset iris, again iris dataset is taken, B SNS facet grid, color species, and you can create a graph with the help of this. So B map, you can see what is going to happen. See again is a kind of a different combination of different kind of graphs are available, similar to the pair plot that we have seen earlier. This is coming with the help of the facet grid. The facet grid has been used here for the purposes of getting, and the data set of course is same, and we are getting 3 grids, 1, 2, and the grids are created here inside. If you see the graph closely, you will see that the grids are also visible. Sepal length, these are the different sepal lengths of different type of, these are the different type of species, Setosa, versicolor and virginica, and this is how this histogram can be created. So these are the again quite by looking at this you can, I hope that you will appreciate that these are very very useful kind of a graphs. The above output clearly shows the comparison between the tips that are given during lunch and dinner. You can always plot using pair grid function, and facet grid object takes a data frame as input and the names of the variables that will form the row, column or hue dimensions of the grid. The variable should be categorical, and the data at each level of the variable will be based on this. So you can see that by writing this SNS set style ticks, A SNS load data set flights, and this again we are intermittently changing the data set also to get different kinds of plots for this, so that we have more like here again you can see that again in the different year wise you are getting the passengers data, because the type of graphs are same, only thing that the data set is different. That is why we are trying to give it so that you can have a better idea about it. Now pair grid allows us to grid a of subplot using the same plot type of visualized data. Unlike facet grid, it uses the different pair of the variable for each subplot. It forms a matrix of subplot. It is also sometimes called the scatter plot matrix. So again, this is just a remark. Then we are using this seaborn figure aesthetics. The first function that we will be discussing is set. We have been using the style parameter. We have seen so many times. This parameter basically deals with seaborn themes. At present there are 5 of them available, namely dark grid, text, white grid, etc. Let's consider the following example and for our demonstration purposes. So when run it, nothing is going to happen. But importing seaborn, matplotlib, SNS white grid, white color codes, SNS dataset is tips here, box plot, day, total bill, and when you run it again, you will see that you are going to get a again a box plot, and day wise you are getting total bill. So this again is something similar to what we have seen earlier. But in the above output, you can notice the theme is changed to white. That is the difference. We can explore it further using the other themes as well. If you notice in the previous output, there are axes present all around the graph. However, this is also customizable using the despine function. Look at the example now. So here again nothing is going to happen, but here yes, code is by and large the same. Day, total bill, despine we are going to use it. So let us run this and we can see what the difference is there. So see here, there is not much of a difference, but again the day wise and total bills are appearing here in the box plot. Now color is basically the feature that approaches the human eyes beyond any other feature. Seaborn allows you to play with colors using various functions such as color palettes, his palettes, hustle palette, etc. So let's try and see that how that affects. So again we are importing the same libraries. Here one more thing that we are going to use it, that SNS present colors. So this gives you this is a palette. Palette means that it is different combination of colors and we can use it as per our requirement. So these are the different color combinations that we have got, and this is known as palette. Now the above image shows the colors that are present within the seaborn. Seaborn has got these many colors, and then whatever new color we want, we can make it with the help of this color combination. So we have done it using the palplot function. For a deeper variation, you can use his palette or hustle palette, HIS palette or HUSL palette, right? So again we can run it, nothing will happen. But sequential color palettes, sequential plots are suitable to express the distribution of data ranging from relative lower values to higher values, appending an additional character S to the color passed to the color. Parameter will plot the sequential plot. Again, since it is a remark, nothing will happen, but yes, we can see that now here you can see just by changing that, because we have talked about the green color. So different shades of green are possible with the help of this. Now this is just for information, not that we are going to use it right now, but if need be, we can make use of these different shades of the color. Now in this case we have used the green color. Now data visualization with tips data set. We are going further onto this, like to check the facet grid, and matplotlib of course is required all the time. Seaborn for for doing all this graphs and plots, etc. Tips data set we are going to have. This is which has been come in the tips variable also. Tips head we can have top 5 records like this. Total bill, tip, sex, smoker, day, time, size. Again data types we can have. Then Again, these are the data types. Columns, we can see what are the different columns. Again, it is the same that we have seen earlier. Shape, again we can find out number of rows and columns. That is possible, 244 rows and 7 columns. Info, again we can see tips info, that is what are the types of this total bill in float or a category or what integer or whatever is there. Describe gives you the statistical information that also we can get, like count, mean, standard deviation, etc. And this is again a kind of a remark. Let us start drawing some graphs. Facet grid is a very useful command for this, so we are going to use the facet grid. So when we write this code like G is equal to SNS facet grid tips, column is equal to day, row is equal to sex. So this is the data that we are transferring into G, which has been now done, and now we are going to create the facet grid with the help of the data that has been transferred to the G variable, and that is about the tips data, giving special attention to day in column and row in the sex. So here nothing is going to happen because we have not given anything, it is all blank, but there are 4 on the top and 4 on the bottom. We are getting the grids. So once we run this, then we are going to get some information, some more information about it. So this is the GNS grid types, time and smoker, distribution, this plot, total bill, color is equal to red. So now you can get that more information with this. So smoker, now you can see that smoker is equal to yes, time is lunch time, smoker comes. Smoker, yes, time dinner, there also, but see the difference in the graph, the peaks. Then here again total bill, in the lunch time and total bill in the dinner time. Now this is slightly more than the lunch time. Now these are some of the things which you can easily, just by looking at the graph, you can make out that how the how the sale has gone, or rather spreads during different days. So and different timings also, lunch times different, dinner time different, what is the number of people that we are visiting and things like that. Now again, scatter plot can be drawn for this, which is like this. You can run that and you can get that, like here the scatter plot for the same, right? Total bill and tip. Now further on to this, G SNS is facet grid tips, then between this time and smoker. Now you can give different comparison for with different variables. So G is equal to G mat, scatter total bill and the tip size. So here again you can get some more information with different variables that we want to get. So you can see that another type of graph may come. See, this is a different kind of a graph, and again looking at this you can see, make out your own inferences from this, right? So it becomes very easy, and I think anybody can do it, but definitely who is an expert who does this kind of a job regularly, he will definitely make out more information from this. The next is here again we are drawing another, like between a smoker and the order, and then again total bill. So again we run it, you can get another type of graph which is again similar to the one that we have seen earlier, that like distribution of this smoker and non-smoker and this total bill. What is the type? Like non-smokers are now more than the smoker ones, right? So these are the types of information that you can keep on getting, and depending on your requirement you can get it. Now here again you can see that the facet grid between a smoker, sex, that means whether it's a male or female, what type of guests or customers who are coming there, what is the comparison between the two. So that again, like here you can see here the spread of the graph, it is slightly scattered, it is slightly heading towards one direction, like sex female, smoker yes, sex female, they are not smokers. So that is what the difference is. Similarly here again, total bill in US dollars, total bill in US dollars. Again, see the difference. You can make out, and you can create your strategy accordingly, that this is the way, this is the pattern that can be seen, and one can easily devise his strategy accordingly. Now, visualizing data in one thing is one thing which is definitely important, but presenting data in the is beautiful manner is another very important aspect. Visualization plays a vital role in communicating quantitative insights people to catch their attention. So that is the purpose of this visualization. So Matplotlib library highly supports customization, but knowing that settings to tweak to achieve an attractive plot is that one should know. That is why more and more practice is required, so that you can improve your graphs in much better way. Unlike Matplotlib, Seaborn comes packed with the customized themes and a high level interface. So you can see that you can keep on improving your graphs every day if you want. Again, importing that Matplotlib, PyPlot, then you are having the sign plot here. Let's see how this can. X is equal to NP line space 0, 14, 100 for I in range 1 to 5. So it will keep on trying that, and it will be a sign plot. We know how the sign plot is made, so we can create a sign plot like this. You can see how this has been made. Now different colors, because we are having different colors that we wanted, and it will generate a sine curve like this. So this again, if you want, you can generate this also. Then the above two figures show the difference in the default Matplotlib Seaborn plots, and the representation of data is same, but the representation style varies in both. So plot styles and plot scale. Again, we can run it, nothing is going to happen. Then import NumPy, Matplotlib. Again, you can have the sign plot. Here again you can have, this is a different kind of a color. See the color difference, right? And the background also. So that is what the difference. So it depends, different types of options are available. Whatever you need and whatever, depending on the requirement, you can go for it. The difference between the above two plots is the background color. See? Now here again you can go for it. This in the white text themes, we can remove the top and right of the right axis spines using the despine function. So that can be done. Now we are going to create a despine graph, like using again the Matplotlib sign plot, and then of course this importing a Seaborn using the same data set, and then we can create the sign plot again. Now here again you can see that the difference. See, there is no background, and there is a little, see here, no grid also is there. So again, these types of things are possible. This depending on again the individual's requirement. So in the regular plot, we use the left and bottom axis only. Using the spine function, we can avoid the unnecessary right and top axis spines, which is not supported in Matplotlib. So we can run this with categorical variable. The new cat plot function provides a new framework, giving access to several types of plots between numerical variables and this. So you can see that we can, this again is a remark, so nothing is going to happen, but we are going to create now cat plot, that is category plot. So again we are using the this code. Data set is tips, again SB cat plot. So day and total bill is the two variables that we are considering, and this is the way we are going to get this kind of a category plot, right? Cat plot again. So this is the shape, cat plot shape we can have. Again violin now we can have, so you can run that. See that we can have a violin kind of a shape of the graph, right? Then of course nothing will happen here, but here we are going to have another cat plot. with the same data set that we are having, total bill. Now we are going to have a boxon kind of a data graph. Boxon we have seen earlier also. Data set of course is same, and this is the way that we are going to get the graph. Now in this you are going to have the so far we have learnt about the scatter plot, hex bin plot, KDE plots, which are used to analyze and continuous variables, etc. These plots are not suitable when the variable under study is categorical. When one of both the variables under study are categorical, we use the plots like strip plot. So now we are going to learn the strip plot and swarm plot. So we can run this, nothing is going to happen. Again, now we are going to understand the strip plots. They are used when one of the variables under study is categorical. It represents the data in sorted order. That is a requirement. So we can write this code like import pandas, PD, seaborn, data set is iris in this case. String plot we are going to create, and because the species and petal length are to be used for this, and data is of course the iris data set. And when we print the graph, this is the way, that is setosa verticular. So that means we are getting a small group of this. So this again is a different type of a graph that we have got. Now with the same graph data that we are getting, the strip plot, we can create another plot with the help of this, and this is something here like this, lines, that where are they falling, getting concentrated, see, these are the differences. Although data is same, but then we are getting this kinds of differences in that. Now here in this import pandas, for this again we are having the tips data, and you will see that another strip plot is going to be created in this like this, right? So this is only one type of graph, and no different colors are there, and all the total bills are only presented here. There is no second variable that has been considered here, right? So that is why it is only one scatter plot that you got. Import pandas as this. Now in the next you are going to have a strip plot, and again data set is tips, and when we run it, you are going to get another slightly different scatter plot with the same data set. Now another strip plot that we are going to create with the help of the same data set, that is tips, and you are going to see now the color, since we have changed the color is equal to green. So you are getting of course the shape of the graph is same scatter plot, but then the color is different. I mean, this again is we must know that if we want, we can change the color. That is what it is. Then import pandas as PD. Now here again tips data set, day, here we are considering two variables, day and total bill. So when we run it, we can see that again we are having this type of graph we have seen earlier, but then this again is possible. So changing the axis, we can change the axis. That means it will go, day will come here and the total bill will come here, like here. So you can see that how to change the axis. So when we run this, you can say the axis will get changed, like here. See, the day has come here, total bill has come here. Now this is again different types of different ways that we can present our graph, and if you need, you can do that. Now again here you can see that the strip plot is created now with the jitter is equal to 0.2. You can change the value of this. The jitter means that it is spread out. You can condense it or you can spread it. So whatever you want, depending on your requirement, you can go for it. Now this again is a strip plot between the data. Let's see what it gives us. Yeah, this is again because jitter plot is 0.02. Here also I think it was 0.2. So see the difference. That is what you can see. Now import pandas as PD, and it's again jitter, and line width is equal to 1.5. Now these are different further improvement that is possible with the same data set. Code is also by and large the same, only very minor changes that you can see. It is possible, like here you can see the change, the differences, right? Similarly, one more graph that we can see is the strip plot, total bill, data DF, and hue sex. So you can see that now we are getting the again 4 data, and we can see the distinction between the male and female. That means how many males have visited and how many females have visited, and what is the total bill like. So the more information that you want, you can get it by writing the code accordingly. Now here, like strip plot, total bill, sex also, and jitter also. Jitter also we have given. So we can give that also and see the difference in the plot. See, more condensed. Swam plot is also possible. We can draw that also. Run, and then we are going to have the swam plot. That is again same. Only thing that we have used the swam plot species. Now it is with the iris data, petal length, and data set, and a data DF, that is the data frame. And we are going to create a swam. This is a shape of the swam, setosa, versicolor, and virginica. This is a shape of the swam. So that is why it is the plot is accordingly. Statistical estimation. In most of the situation we deal with estimation of the whole distribution of the data, but when it comes to central tendency estimation, we need a specific way to summarize the distribution. In all the plots that we learned so far in the above section, we made the visualization of the whole distribution. Now let us discuss regarding the plots with which we estimate the central tendency. So that is the purpose of this. So we run it, nothing will happen here, but yes, bar plot of course can be created, and the bar plot shows the relation between a categorical variable and a continuous variable. The data is represented in rectangular bars where the length of the bar represents the proportion of the data in that category. Bar plot represents the estimate of the central tendency. Now we are going to use another data set. If you remember, we used Titanic data set, and here we are importing that data set, that is Titanic. Count plot is equal to X, how many have survived. Data is equal to data frame, which is there. Run it. So this will do whatever we want it to do. That is done, and then we are going to have a bar graph. That means this is the survived, and this is the count like, right? Now further on to this, we can run this count plot, and then sex wise, that is how many males and how many females, and this is the count like. Further we are going to have like SNS factor plot, survived, sex, kind, count, etc. So we can see that here survived males and survived females, like here male and female, and this is the number. So you can see that as much information you want, if the data is available, you can do just by writing very small code. Now here again you can get the sum of that group by sex wise, like here female 233, male 109, and this is the way that we can get the summary. Then run this again, you can have the total this print df survived sum, this total number of sum, survived count and survived this thing. So both male and female you can get that. So this again is, now here we are going to have the count plot again. Next, import this, you can have some more information with this, like a matplotlib, pyplot, cat plot, sex and hue survived and kind. Like here you can get that in male how many have survived, and female this survived is this, right, and this is the count like, right. in female, this is the how many have survived and how many have not survived. Then DF types. This again is a different types of data set that we have. Cat plot earmarked. Hue, survived and kind count, P class, passenger class. That again in different types of classes, passenger classes, what is the situation? That also we can get with the help of this. So embarked, hue, survived and kind plot, and PC class, passenger class, and data is DF. Right? Now here again you can get some more information like survived, then embarked, kind count, and again you can get that. So see, this is something like again survived, different classes, right? Here SCQ, these are the three classes that we have. Then use Seaborn distributed plot, you can get that also with the help of this. So see here how this total distribution is taking place. Where KDE falls, it is so that is how you can get this graph also. Now you can run this also, use a pandas plotting method to plot the column fare for each column, for each value, and survived and not survived. So how much fare has been paid and how many of people have been survived. So you can write again this code and you can see that what is the kind of graph that you get, how many people have survived and what is the fare like. All such things are possible with the help of this code. Now use Seaborn to plot a histogram of the age column of this. So here nothing is going to happen, but we can have the drop not applicable or nan, and then you can get some information more about this, about the people who are there, that is age wise, how many people have survived, right? So as much information as you want, you can keep on getting. That is why you have to keep on digging it. Only consideration is that you must have that data, and data should be right. That is very important. That is why emphasis should always be given on the data. As good data is there, as perfect data is there, your analysis is going to be also very, very good. So SNS LM plot. Now this again is a different kind of a plot. Age, fare, survived, data is this, scatter KWS, and once you run this, you will see that you are getting you see complete. All the data points are there, and this is all very congested kind of a data set that you are getting. So you can see that how although it is also a scatter plot, but it is very congested. So it is better if we use other plots. Bar plots. To make a bar plot, you need to calculate the count of each category. First you need to install all the required libraries, and using we can also change the default fixed size. So all that is we have seen so far quite a bit, so that can be done, not much of a problem. Then import all the libraries which are required and go for the RC params and update and go for the figure size. So here of course nothing is going to happen. In this also nothing will happen as such, because this is also a remark. So you can create some data A, B, C, D, E up to I, and then see that a kind of array will be created with the help of this data that we want to. And simple bar plot using matplotlib can be created. So for plotting a bar plot, you can have different kind of a like here you can go for the bar plot. So once you give this like plot BR bar and then X label, Y label, categories, values, etc., the data has already been created by us here, right? So the same data is being used here. It is not coming from any other side. So category, etc., we can, and you can see that A, B, C, D, E, I, whatever we have done, It is all that available here, and this is the categories, and this is the bar plot, and values are like this. That is also we have given there. Now similarly for horizontal, now the same plot can also be seen horizontally. So how to do that? Again, PLT bar H. Now we are giving the bar H gives the bar horizontal, right? So X comma Y, the same values are going to be there, categories and values, etc. And you can see that once we give a command to draw it, the same plot will be presented in the horizontal form. Now sometimes you need this. If you don't need it, of course, no need to go, but sometimes you need to present it in a different manner. That also can be done. Now changing color of the bar plot is also possible. That is again, so bar plot, again XY color, fabric, green, black, or whatever colors we want, we can give it, and then plot X label, then Y label, categories, values, etc. The same data that we have created earlier, the same data, but now we are creating a different colors. And see, different colors have been used. Now next is stacked bar. Now stacked bar can also be done. The stacked bar we have discussed earlier also. Chart stack bar that represent different groups on top. This can be done in pandas library like this. So we can run this, nothing will happen here, but then here we are going to have this. So once we run it, like here you can see all the libraries, then survived, died, and then this is also like, you know, for the Titanic data set that we are using, and we can have, say, again a different kind of a graph with different colors, that is, and stacked. That's important. Stacked, then blue color is what? 1, 2, 3 stacked bar plot. So this is how you can have the, you know, say these many have been, you know, survived, and these are people who have died in that, you know, episode. Right now, different palettes. The above graph is categorical based on whether the passenger survived or not, and also stacked based on the class in which the passenger is traveling. So let's use that. That is also possible with the help of this palette, different colors that we can have. So survived, lock DF, survived 1 and survived 0, value counts, then DF plot data frame is equal to survived and died, index is equal to survived, died, and then you can run this. So you can see that a stacked bar will be created, and this is something like this: survived, died, and this is like, you know, female and male. So you can get complete information, and you are getting almost as accurate as possible, right? So this is how it is possible with the help of this kind of a code: plot, and then stacked, color maps, special, then titles is equal to stack bar, which is there, stack bar, plot, and special spectral palette, and all these things are possible with this. So this again is a very useful plot that we can have. Now the above graph is categorical based on whether the passenger survived or not, also stacked based on the number of siblings of each graph. The difference between the two bar graphs is that grouped bar graphs used. So we can again, you know, run this. This of course is a remark. Now we can have the import matplotlib maps cm dated ends with. So when we print this, you can see that, you know, all those variables which are there in this are going to be available to us. I mean, different kinds of colors, like maps, M for M in CM, day, and if not M ends with. So these are all the different kinds of color combinations which are there, which we can use, and we do use it. Now here again, like violin plot, again this I think we have done it earlier. No, this of course, like, you know, this kind of a graph. Now this is for the Titan data set. So that is why, because it is giving us the sex, age, and survived. These are the two parameters that we have taken into consideration. 0 is survived, 1 is this is between the male and female. So this is how we can keep on doing it. Now heat map, group the data set by P class and passenger class and survived, etc. So we can run this, nothing is going to happen. Then group by, so you can see that group df group by passenger class survived and passenger class survived group size unstacked, and this is the kind of a heat map that we can have with the help of the same data set with of course the annotation that we have. So passenger class survived, and you see you can get a good heat map with the help of this code. Now here we are going to again count this, and then we can get this kind of a bar graph, first class, second class and third class, and this is the way we can get it with the, because the palette we have used as blues only, that means all these, but we have to distinguish, so different shades of blue color are available there. Now we can easily understand from the plot itself that the number of passengers in the third class are higher than the first and second class, which of course the graph tells us. So it is there's nothing to think about, it is obvious. So we can run this. Then plotting wide form of data, it is always preferable to use long form or tidy data sets, but at the times we are left with no option rather than to use a wide form. So data set, some functions are also applied to the, so this is for information, for our better understanding. So if you go through this, you must read it so that you can understand it better and better. Like again here we are importing all the libraries, and then we are going to print a box plot with the iris data set. Now iris data set, you can see that it is this kind of a horizontal kind of a box plot that we are going to get, right? So this is how you can create a, and like here why it has come as horizontal, because we have written a SB box plot data is equal to df, orientation is h is horizontal, h indicate that it is horizontal, that means we have reoriented from vertical to horizontal that we have given. The next is, additionally these functions accept vectors of pandas or numpy objects, so we can run this. Then again we can import all the libraries, and then we are going to have a violin kind of a thing, plot, that also is possible, and we can have this violin kind of a, right? Then factor plot kind violin, we can have different plot to visualize the same data, but then we can visualize in a different way. That is what is done with the help of the visualization. That is what the purpose is also of a visualization. So we can do that also. And you see, this is the kind, rest, walking, sleeping, same, So that this is how we can do different kinds of graphs. If one graph is not very clear, we can create another graph and we can understand it. What is facet grid? That facet grid has been explained. Facet grid is a matrix of panel defined by row and column by dividing the variables due to panels. A single plot looks like multiple plots if it is helpful to analyze all combinations into discrete variables. So we can run this, nothing will happen. But here, yes, we can use the factor plot. So factor plot, when we use after writing all these codes, this is again a data set is of course exercise, time, pulse, kind, and you are using the again violin kind of a plot. The advantage of using facet is we can input another variable into the plot. The above plot is divided into two plots based on the third variable called diet using the column parameter. So that is possible. This of course, you keep revising it or going through a couple of times, then you will learn more and more about it. That is the purpose. So you can see here the again Titanic data has been taken, and factor plot alive column is equal to deck, and when we run it, then you can see a different kind of a this bar graph has come in, and you can see that again different kind of a these are the classes. Then deck DEF is available, and you can see that 2 rows of this graph has come in. So, and the third way, the third graph that you can see in the bottom, that is so small. So that is why you can see that everything in detail is available to you, and you need not go for any other analysis. Just by looking at these types of graphs, you can get your job done. Facet grid, as usual approach to explore medium dimensional data, is drawing multiple instances of the same plot in different subsets. This technique is commonly called as lattice or trellis plotting, then, and is related to the idea of a small multitude. To use these features, data has to be in pandas data frame. So this is something which we have to keep in mind. Plotting small multiples of data subsets, and then we have already seen the facet grid example, that of course we have seen. Class helps in visualizing distribution of one variable as well as the relationship between multiple variables, that also we have seen. A facet grid can be drawn with up to 3 dimensions, row, column and hue. The first two have obvious correspondence with the resulting array of axes. Think of the hue variables as a third dimension along the depth axis, where different levels are plotted with different colors. So we can run this, and then we can also write code for this. So import pandas SPD, and then seaborn, matplotlib, df, and the data set is of course tips. Facet grid we are going to have. So when we run it, you can see that again facet grid will be created, and you can have the 2 kind of a blank grids are created with the help of this. Now in the above example, we have just initialized the facet grid object, which doesn't draw anything on them. The main approach for visualizing data on this grid is with the facet grid map method. Let us look at the distribution of the tips. So we can again, after understanding this, whatever is mentioned, we can run this code. Import pandas, then tips data, facet grid, df, column time, gmap, plot hist, and then tip. And you can see that now in the same grid which was created here like this, you are having the proper histogram, that is tip here and tip here, then the lunch time and dinner time. What is the difference like? You can see the difference in this, and you can definitely draw your own conclusions from this. The number of plots is more than 1 because of the parameter column that we have given, and to make relationship accordingly. So it is all that whatever we want, the way we want, it can be done with the help of this. Now here we are going to use the tips data, and we are creating a facet grid. Now we are going to have multiple. Matplotlib is being used here, and you can again see this. See the 2 graphs, more than 1, male, female, and then this is the way it is distributed, total bill and the tip, right? So this is how you can keep on creating more and more detailed graph, informative graphs. Now the pair grid, here we are using this same that iris data set, pair grid, and then scatter plot is going to be created in this, and then you can have again a different type of a scatter plot here in this case. So we can see that the another type of graph is coming for us, and we can go through and understand and draw our conclusions. Now see, this is again, you know, created with the help of the same iris data set that we have, and you can see sepal length, sepal width again, and at the bottom you can see this is the petal width, petal length, and the sepal length, sepal, and this is the petal. So you can see that different combinations of this data set that you have, in different way you can present, and definitely those who are having a expertise knowledge, definitely they can draw their own, you know, conclusions and make use of this in formulating their strategy for that. It is also possible to plot a different function on the diagonal to show the unvariate distribution of the variable. So we can run this again as a remark. Then here we are having matplotlib pair grid map and diagnosis split. So you can see that we can draw another kind of a graph here, and this will be again a kind of a pair grid, pair plot that we can have, and we can definitely make use of this for different purposes. See, this again is a, earlier if you see, it's a different kind of a combination of, different kind of a graph, but here it is the combination of histogram, scatter plot, and all that. Again, the data type is similar. We can use different function in the upper and lower triangles. If you see, different aspects of relationship is also possible with the help of this. Then the next is import pandas SPD. Then again you can have the upper plot is scatter, lower KDE plot. Now here we are going to have a different kind of a. So if you run it, you will see that now it is a different. Here we are having this, 4 graphs in a row, and like that 1, 2, 3 and 4 by 4 matrix has come in. And here if you see, when we run this again using the same data set, that is iris pair grid, that is the data frame that we are having, and map upper plot is scatter, and lower we are going to have KDE plot, and it is going to be blue distributed again, right? So we can have this. It takes some time because again, so many graphs are going to be created and the data is also quite big, so that is why it takes little time. So it has come now. Now you can see that again a different type of graph that we are seeing. The scatter plot of course is there, that we have already mentioned in this, like here scatter, but the other graphs are different. They are joint plot, they are normal distribution graph. These are the joint plots. These are the normal distribution kind. This is scatter plot. So it's a combination of both. That is how you can get this kind of a graph, right? The next is that Anscombe data set created by a French scientist that consists of 11 XY points. They were constructed in 1973 by the statistician Francis Anscombe to demonstrate both the importance of graphing data before analyzing it and effect of outliers and other influential observations on statistical properties. So if you have heard this person's name, you will definitely know about it. If not, you can find out. But this is what he has done. It is also known as Anscombe quartet. Comprises 4 data sets that have nearly identical simple descriptive statistics, yet have a very different distribution and appear very different when graphed. So let's see. So Allen plot with Anscombe data set. Now he's created his own data set for that, and he has used it using, of course, the Seaborn, Matplotlib, statistics, and load and data set is Anscombe itself. He's given the name also Anscombe, and then LM set. This is the way that you have to write it. X is equal to X, Y is equal to Y, column data set, hue is data set, data frame is DF, column wrap is 2, CI none, palette muted, height 4, scatter KWS, and then when we run this to show it, you can see that you will get a different kind of a graph. See here, a different kind of a graph, scatter plot, and of course a line also is available to you. Colors are also different. But that is how you can create a Anscombe. Using Anscombe data, you can create a graph line. This is a kind of a linear regression, if you remember. Violin plot with the tips data set can again be created, which of course we have seen, but just to remind, just to understand it further, you can get that. This is a bigger violin kind of a graph that we have got. Only one violin has been created. Now horizontal box plot can be created also. That is also possible like this. Earlier we used to give vertical, we have seen, but now you can have this also. Pair plot with tips data set is again can be done. See, now after this we can have the that pair plot also for this tips data set, and this again is something which of course similar types of things we have seen, but here we are having 3 rows in this, in each of this, right? So that also is possible, and these are quite useful. Then you can get pair plot, then pair plot tips data, run it. Yeah, you see how beautiful it is, different colors, different types of graphs, different like total bill, tip, male, female, all the details are available within this, and one can definitely study and draw his conclusions with this. Size is also mentioned, that means how many people in a group have gone there in that restaurant. So such type of information are available, and one can definitely make use of this the way he wants it. This is of course the count plot tips, again like different days, different counts, again all these things are available. Yeah, see some more information. Thursday, Friday, how many males, how many females, all such things are available. Friday they are lesser, Saturdays again more, Sundays again more. No, these are the things, just apparently you can see, you can make out. Then in distribution plot with this, then again you are getting some more information about this. Like this is a normal distribution graph that also can be done, like distribution plot, right? Then we are coming to the a very important and very useful graph, that is funnel chart. Now this is something which you want to, funnel charts are often used to represent data in different stages of a business process. It's an important mechanism in business intelligence to identify potential problem areas of a process. For example, it is used to observe the revenue or loss in a sales process for each stage and displays values that are decreasing progressively. Each stage is illustrated as a percentage of the total of all values. So that is what the explanation given for that. And then how to draw that funnel chart is import plotly.express as px. Now this is a different kind of a library which is available, which can be used. Data is equal to dictionary number 3927.4. This data is you have to accept it, because whatever data you have, you can try with that. Stage, website visit, downloads, potential customers, requested price, and invoice sent. Now these are the variables that have been taken into consideration. Figure is px funnel, data x number, y stage. So this is of course hypothetical data, but yes, to present it how this can be done. So these are the data, actual data points. These are the various variables under which the data points are there, and these are the variables that are being considered for this kind of a plot. So this is known as a funnel plot, because it is mentioned also fig is equal to px funnel, data, and x number and y stage. So you can have a good funnel kind of a chart with the help of this code. See here. Now this is the kind of a website. So number is given, stage is given, downloads are there, potential customers, requested price, and you can go through all that and see that where you can fit in according as per your requirement. Now similar type of plot can further be drawn with a different kind of a color combination. So like here you can break it. Now if you want to have the same analysis done in two different places like Montreal and Toronto, you can do that also, right? See how it is done. You get office this and number this, so you can have this kind of information, right? Additional information which you are getting. So this is very useful and very informative. Furthermore, if you want, you can again go for Plotly Lab. Of course, this is again the same, but now you are going to get again furthermore different blocks have got different colors. Data is same, everything is same, only thing that presentation is different. Okay, so this is something which is, and you can apply in any business, because different processes are always there and every process takes its own time. There may be some problem, there may be some delays and things like that can be taken care of in these kind of graphs without asking anybody, just to get the data, and you can get the details like this. Now let us move on to the dendrogram. Now dendrogram we have done earlier also, but now let us see that how the dendrogram can be created with the help of this data like iris. So if we use this iris data set and then using of course the heat map, C bonds, and species, and then you can draw a dendrogram is like this on top, and the similar thing is available for a small portions. It is available here. Sepal length, petal width, sepal width, petal length, and you can see that this again is a. So here of course this data may not be that appropriate for this, but to make the graph how it is made, that is something which is explained here. So you can have a good dendrogram using the seaboard. Similarly, here you are having change the size of the layout, SNS cluster plot. You can have the again iris data set, and you can run it. It is a cluster map using iris data set, and you can get this type of a graph, which is again a seaboard. Then this is a dict in a row cluster map using the iris data set. That is also something similar to that, again dendrograph, and then you can have this, and then use a different color map also you can do using that. You can have a different kind of color combination. C map is equal to MACO, V min is equal to 0, V max is equal to 0. So you are having a different color combination of blue, different shades of blue and black, and again dendrogram. So this is the way you have seen so many types of graphs and so many kinds of visualization which is possible with the help of the data visualization, and it is very helpful. Half of that, in fact more than 50% of job can be done with the help of just the data visualization. Thank you.